All right, so welcome back, ladies and gentlemen. We're going to talk about section 4.6 today and tomorrow, and we're going to start with the fundamental theorem of algebra. The fundamental theorem of algebra simply states that the highest degree is equal to the number of solutions, and that also includes repeated solutions. Remember, a repeated solution is one where it just touches the x-axis, and we would call that a multiplicity of 2. So, example 1, how many solutions does x to the fourth minus 2x cubed plus 5x plus 12 equals 0 have? So again, look for the highest degree. And it looks like right there it's 4. So the highest degree is 4. So it has 4 solutions. And how many zeros does the function f of x equals x cubed minus 6x plus 21 have? And on that one, you got a 3 there. So it has 3 solutions. All right, so on those, it's just kind of telling you what to do there. All right, how many solutions? And then after we do that, the next example shows find all the zeros of f of x is equal to x to the fifth plus 3x to the fourth plus 9x cubed plus 23x squared minus 36. Step 1, remember what we would do is we would take our p over q. So we would find all the factors of 36, all of the factors of 1, because remember it's a 1 in front of the x to the fifth there. And as you can see, we have 1, 2, 3, 4, 5, 6, 7, 8, 16 possible solutions. So on something like this here again, what you should do is you should graph it. And I did graph it for you here. Let me just bring it up quickly for you so I can show you. So there's the Desmos graphing calculator there. And as you can see, it touches the x-axis at -2. So that means that we have a multiplicity there. Remember, it's an even function. So we're going to have 2 solutions there. And it looks like we also have another one at 1. Okay? But now remember, what it's telling us here is we need to have how many solutions? Well, what is your highest degree here? Your highest degree here is 5. So you know that you have to have 5 of them. We at least saw that we have 3 of them. We'll see how to get the other 2 here in a second. So step 2, use synthetic division. I just showed you the repeated 0 at -2. And the 1. So here it doesn't matter which one you choose, ladies and gentlemen. Just remember that you're going to get a 0 for your remainder. So on this one right here, let's go ahead and look at it. Oh, look, there's no x here. And what do we do when we have no x? We would put a 0 there. So don't forget 0 for x term. Okay, so I went ahead and I started with the -2. All right, so I tried that one there first. And remember, I'm going to now put 1, 3, 9, 23. Don't forget your 0 and -36. Okay. Remember, we should have that line there. And again, we hope we get a 0 here, right? We hope we get a 0 there. Because we should, we expect it. So again, remember, I bring down the first one. Let me see, that's kind of sloppy there. So I bring down the first one, which was a 1. Negative 2 times 1 is negative 2. 3 plus negative 2 is a positive 1. Negative 2 times 1 is negative 2. 9 plus negative 2 is a positive 7. Negative 2 times 7 is negative 14. 23 plus a negative 14 will be 9. Negative 2 times 9 is negative 18. 0 plus a negative 18 is negative 18. And negative 2 times a negative 18. Negative times a negative is a positive. So again, we have a 0. And again, that is what we expected. Okay. Excuse me. So now you could do the other negative 2. You could do the 1. It doesn't matter. So I went ahead and used 1, but now remember, what you're going to do is you're going to use these ones here. So again, I have my 1 there. And now I have 1, 1, 7, 9, and negative 18. Again, I'm going to put a line there between the 9 and the negative 18, and we're just going to do the same thing. So 1, bring the first one down. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. 7 times 2 is 9. 1 times 9 is 9. 9 times 9 is 9 plus 9, excuse me, is 18. 1 times 18 is 18. And again, we got a 0 as expected. Okay, so those are 2 of our solutions. Remember, we need to have 5 of them. We'll see that our next one here will also work. Again, I'm going to take my 1, 2, 9, and 18. And again, since it was touching at negative 2, I have to have 2 of those there. So I do this again. Okay, I bring down the first one. Negative 2 times 1 is a negative 2. So 2 plus a negative 2 is a 0. Negative 2 times 0 is 0. So 9 plus a 0 is 9. And negative 2 times 9 is negative 18. And again, we get a 0. And again, that's what we expected. So those are the ones that we could easily see from our graph. Okay, so now what are we left with? Again, we have, that's our remainder. Remember, this is our constant. This here would be our x, and this here would be our x squared. So we have x squared plus 9 left. And again, remember, that is equal to 0. So we're just going to solve that. So if we solve that, we'll take x squared. This one's pretty simple. We'll put the negative 9 on the other side. Remember, to undo a square, I square root it. Again, we're going to put a plus or minus there. And that will give us a negative 9. Oh, but can we have a negative under the radical, ladies and gentlemen? Of course we can't. So we know that we have to write that as x is equal to plus or minus 3i. Okay, so f of x then, here's how we broke it up. Remember, this will be x plus 2. And remember, since there's 2 of them, that tells us we have a multiplicity of 2. We could write it as that. And then we have our x minus 1. Then we have our x plus 3i. And we have our x minus 3i. And you can say, and the zeros. Are, again, I told you it's negative 2, negative 2, positive 1, negative 3i, and a positive 3i. Again, there's 1, 2, 3, 4, 5 solutions. Since we had x to the 5th, that's what we expected. And again, tomorrow, the notes for tomorrow, we're going to just again do a conjugate like we just did with the last one on section 4.5. That should do it, ladies and gentlemen. I'll see you tomorrow. Thank you.